Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 3 from the October 2021 paper 4 0580, paper 4 variant 2. And this question number 3 here is about trigonometry, and we have this pentagon which is made up of these 3 triangles. Basically, they've taken the point A and joined it with the other points in the pentagon to form these 3 triangles, and one of those triangles here, ADE, is a right angle triangle, and they're asking us to calculate AD, the length of AD, showing that it rounds to 94.5 meters, correct to 1 decimal place. Okay, so let's call this length X, and we have to find this length X. All right, now, as I mentioned, this triangle ADE looks like it's a right angle triangle. It's a right angle triangle because there's this marking here. So we know it's a right angle triangle. And for right angle triangles, we can use the trig ratios, sine, cosine, and tangent, SOHCAHTOA, TOA. Now for the sine ratio, so we can use one of these trig ratios. Now here we have a right angle triangle. We have been given a side, which is DE 46.1. We have been given an angle AED, and we have to find the side AD. Now we have to think about what sides we have been given in relation to this angle, and we can see that the sides that we've been given in relation to this angle, if this is the right angle, this is the hypotenuse. So we don't know the hypotenuse, but we know the side opposite the angle, and we know the adjacent side. So we'll be using the tangent ratio. So we're going to be using the tangent ratio to answer this question. So we're going to say that the tangent of the angle given, which is 64 degrees, is equal to the opposite, which is what we have to find, X, over the adjacent, which is 46.1. Opposite of adjacent. So that means X is equal to 46.1 times the tangent of 64 degrees. And that will give us our value of X. Alright, so we have to first make sure our calculator is in degree mode, which it is. If it wasn't, in this particular calculator, you press Shift and Menu and Angle Unit, and you press 1 for degrees. It's in degree mode. So we got 46.1 times the tangent of 64. Close that bracket there. You're going to end up with 94.5190. So 94.519, 94.519. Now, a very important point about this particular question, it says, show that it rounds to. So don't just write 94.5 straight away. Write it to a few more decimal places, and then you can say, therefore, AD is equal to 94.5 meters. Okay, because it rounds to 1 decimal place to 94.5. So writing down this particular step is very important. If it says show that it rounds to, okay, that's something that you should always keep in mind if it has that type of question here. And then it says for part B, it says calculate angle BAC. All right, angle BAC is the angle over here. Now I'll just write down what we have found. There's 94.519. This is 94.519, but we don't actually need that for this. Angle BAC is the angle over here. Let me call this angle theta. Okay, so this angle is the angle we have to find. Now this is a triangle which is not right angle triangle, so I can't use SOHCAHTOA. I can't use like the trig ratios for right angles. Here I have to use something which involves non-right angle triangles, and we know this could be the sine rule, it could be the cosine rule. In this case, for the sine rule, we need to have pairs of opposites, and we can see that these are opposites, and one of them is what we have to find. That's fine. And these are opposites, and we know both of them. So there's only one unknown over these 2 pairs of opposites. So then that's like the perfect example where we use the sine rule. So I can say the sine of the angle that I'm trying to find, which I've called theta, over the length of the side opposite it, and this is what the sine rule states, will give us exactly the same answer as the sine of another angle in that same triangle, divided by the length of the side opposite. That's that angle. So as long as they're in the same triangle, then an angle divided by the sine of an angle divided by the side opposite that angle divided by the sine of another angle divided by the side opposite that angle will always give you the same ratio. So now we can just rearrange that and say sine theta is equal to 56.5 times the sine of 94 degrees over 78.4. Okay, so now theta will be, now I can take these and I can find the answer. Now what I'm going to do here, this answer that I have already from the first part, in case I need it in another part, I'd like to save it in a more accurate form. I could write it down like this again, or I could actually save this original form in my calculator. And you do that by pressing store, and then I'm going to press this button for the A. It's now stored under A in the calculator's memory. So if I need to use it again, I can recall it as A, as I'll show you in the next part of the question. But now I don't need that for this part of the question here, because none of them are the same as that. So you know, that side is not needed in this part of the question. So now I'm going to find what theta is. Now, if I just put this in my calculator, that will give me the sine theta equals a particular ratio. I want to find the angle which has that ratio, so I'm going to press inverse sine of this whole thing. So I'll put my fraction 56.5 times the sine of 94 divided by 78.4. Just make sure I've typed everything in there. Sometimes you miss a point when you press the button, it doesn't work, or it doesn't press it properly. So there we're in degree mode. When we press equals, it will give us the angle which has this ratio, because I press inverse sine. So it's going to give me the angle that gives me this ratio, which will be our answer, which is 45.964, 45.964 degrees. Now angles should be given to one decimal place unless otherwise specified. That's 45.964. That's going to give me 46.0. 45, is it 964? 45.964. Yep. Okay, so that's 46.0 degrees. If you round this to one decimal place, you're going to get 46.0 degrees. And there is the answer for that question. Question part 2. So that's 46.0 degrees over there. Rounded to one decimal place. Then part 3 says calculate the largest angle in triangle CAD. I'll just write here what I know for this. This is going to be needed, I think, in this question. Okay, so we want to find the largest angle in this triangle CAD, which is this triangle over here, this middle triangle. Now the largest angle in any triangle, okay, is always going to be opposite the longest side. So it's just like to give you a extreme illustration. The largest angle and the longest side are always opposite each other. The smallest angle and the smallest side are always opposite each other. So here, this obviously is the largest side, so this must be the longest or the largest angle. So I'm going to call this angle alpha, right? And here we have all three sides of the triangle. When you know all three sides of the triangle, it's not a right angle triangle, okay, then we can use the cosine rule. That's a typical classic example of using the cosine rule when you know all three sides and you have to find an angle. And when you're finding an angle, the cosine rule, you can memorize it in this way: b squared plus c squared minus a squared over 2bc. Now some of you memorize it as a squared equals b squared plus c squared minus 2bc cosine a, and that's fine. When I'm finding a side, I'll use it in this form because it's like you got the side as the subject. When you're finding an angle, it's basically the same formula and just rearrange to make cosine a the subject. Add 2bc to both sides, take away a squared from both sides, then divide both sides by 2bc, you end up with this. This is the form that I'm going to use because it's already set up for us as we need. But you must be very careful what you do when you use the cosine rule. Okay, now the angle here and the side here must be opposites. So if I'm trying to find the largest angle in the triangle, which is, you know, this one, I must use the largest side in A. B and C, it doesn't matter. A has to be the side opposite the angle we're trying to find. So I'll say cosine of alpha is equal to b squared plus c squared. Now b and c, it really doesn't matter which one you choose. So I'll use 38.6 as b, plus and 78.4 as c, then minus a squared, which is our answer from before, for 94.519. I'm not going to use it as its rounded form. I'll use it in its more accurate form. And I'll write 95.519 dot 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 to show that I'm using a more accurate form of it, over 2 times 38.6 times 78.4. Now, when I find the inverse cosine of all of this, I will get the angle that I need, which I need to round to 3SF. So I'm going to put inverse cosine this time. I'll get my fraction ready. Okay, and I'll close the bracket ready. Now I'm going to put in here 38.6 squared. So 38.6 squared plus 78.4 squared. 78.4 squared minus 94.519 squared. Now what I'm going to do, as I already saved this answer inside the memory, I'm going to press recall, which is shift and this, and then you see A is saved as what I saved it as, 94.519. So I'm going to press A here, and it's going to give me A, which is that number, which I need to square, divided by 2 times 38.6 times 78.4. Okay, so that's 38.6, 78.4. Okay, good. So I'm press equals, and that will give me 102.377, 102.377 degrees, which rounds to 102.4 degrees. Remember, the answer should always be given in degrees to 1 decimal place. So that's the answer for part 3 of this question, which is 3A, which is all about trigonometry. Now, what's 3B about? 3B about is also about trigonometry, I guess. So I'm going to carry on this same question in this same video. So let's go on to this one now. Okay, so this question says triangle PQR has the same area as triangle LMN. They have the same area. Calculate the shortest distance from R to the line PQ. Okay, so now in this question here, we're forced to use a particular understanding that we know. Now, first of all, the shortest distance from a point to a line. Okay, for example, if I have a line here and I have a point, okay, the shortest distance from a point to the line will always be the perpendicular distance. See, these will all be long. This is longer, longer, longer. Shortest distance is when they meet at right angles. When they meet at right angles, that will be the shortest distance from a point to a line. So the shortest distance between R and PQ is going to be the line between R and PQ that is at right angles. Okay. Now the key to answering this question is to understand that this is what I'm trying to find X. Okay. That in this triangle here, this can be thought of as the vertical height of the triangle, and this as the base. The area of a triangle is a half times the base times the height. So in this triangle, the area can be thought of as a half times the base, which is 34.3, times X, which is the height. Okay, so this is like the base and this is like the vertex. The vertex to the base, that's the vertical height of the triangle. All right, so if you turned it upside down, you'll see in that form that this is the height and this is the base. Now, we don't know the area of this triangle, all right, directly, but if I knew the area of this triangle, I would be able to find what this length is, which is the shortest distance from R to PQ. Now, in this question here, they've told us that this triangle has the same area of this triangle. So we can say the area of LMN, the area of triangle LMN, is equal to, now we know another formula for the area which involves non-right angle triangles, which is a half AB sine C. So basically, if you have two sides and the angle between those two sides, you can find the area of the triangle by using the product of those two sides times the sine of the angle between them times a half. Okay, basically what this is, it's the same formula as this, but you're finding the vertical height of the triangle. Basically A sine C is the vertical height of the triangle. So it's basically the same formula where you've found the vertical height of the triangle by using this formula. So this formula will give us the height or the area of any triangle, whether we know the vertical height or not, as long as we know two sides and the angle between them, which we do. So it's going to be a half times a half times AB. So it's a half times 21.5 times 27.6 times the sine of the angle between them, which is 111. Okay, so we can say now that a half times 34.3 times X is equal to a half times 21.5 times 27.6 times the sine of 111. Those two are going to be equal to each other. If I multiply by those sides by 2, the halves will cancel out, so I can say our length is going to be 21.5 times 27.6 times the sine of 111 over 34.3. Okay, just this is the area of the triangle. This is the area of both triangles, as they're both equal to each other. So this will be the area of both triangles. So this half times the base times the height is equal to this area, and I can now find what x is very simply by just sticking this in my calculator. So I'll have here 21.5 times 27.6 times the sine of 111 divided by 34.3, and that will give me 16.151. Okay, it's an area, so rounded, it's a distance, sorry, round to one decimal place, to 3 significant figures. Okay, so it's 100 and also it's 16.2 centimeters. That is the shortest distance from R to PQ. Okay, so there's the answer, part B, and that's the end of that question number 3. Okay, so this question is all kind of linked to trigonometry. All right, so that's the answer to that. Thank you for watching. Other questions which are related or from this paper can be found in the playlist over here. Other questions to do with trigonometry in IGCSE Trigonometry can be found in this playlist. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.